Across labs and observatories, a startling statistic has been making the rounds. The probability that two interstellar objects would slip into our solar system from roughly the same patch of sky, just a few years apart, is so remote that many researchers now call it vanishingly small. And yet, here we are. Far beyond Mars, something unexpected is unfolding, quietly, steadily, and in full view of the most powerful eyes humanity has ever pointed at space. NASA's instruments have just caught a departure, an object peeling away from the interstellar body known as 3I Atlas. What was long filed under harmless traveler of rock and ice is acting out of character. It released something. That something isn't just drifting. It is moving with intent. If this story finds you anywhere on Earth, consider it a shared moment. Wherever you're reading from, you're part of a global audience watching a new cosmic question mark being drawn across the sky. This isn't only about data points and spectra. It's about wonder and about what it means when the universe does something we didn't expect, what we thought we understood. When 3I Atlas first appeared in our records, it fit a familiar comet-like profile, a frozen remnant from elsewhere, a glow with a soft green that chemistry can explain. That color, so photogenic in telescope images, comes from diatomic carbon fluorescing in sunlight. The catalog entries accumulated, numbers were logged. The narrative was neat. Then the pattern cracked. The Solar and Heliospheric Observatory, SOHO, picked up a flare. Brief, crisp, and odd. Not a puff of gas, not a dusty plume, a structured emission, a pulse of light that rose and fell not chaotically but with cadence. It flashed for only seconds, but it left behind a fingerprint that set teams at NASA, Harvard, and the European Space Agency into overdrive. A second component takes flight. In the aftermath, instruments in both optical and infrared bands recorded a smaller body prying free from 3I Atlas. Initially, the default explanation held, likely volatile outgassing as sunlight warmed the surface, producing jets that can fracture and push off debris. Routine, if dramatic. But when the James Webb Space Telescope delivered its take, the routine explanation stalled. The breakaway wasn't a shapeless spray. It carried geometry. Its reflectance profile diverged from the parent object. And, more unsettling still, it seemed to emit a faint radiation signature of its own. Symmetry where we expect disorder. Nature is generous with asymmetric chaos, uneven eruptions, ragged fragments, chance. What Webb's spectrometer hinted at was something tighter, more ordered. Analysis traced ionized metals, silicates, and a recurring motif in the emission lines, an interval that repeated every 42 seconds. Researchers have labeled it a repeating spectral anomaly. Official statements stop short of the word artificial. Off the record, the conversations are livelier. A nudge that won't average out over a continuous 72-hour watch. The fragment didn't merely coast. It accelerated by roughly 0.3 ms, not in fits and starts, not as a jittery response to random jets or gusts of solar wind, but with a steadiness that makes statisticians frown at the idea of coincidence. That steadiness is what engineers call a signature of control. Call it what you like, guidance, active response, primitive propulsion. The behavior doesn't slot neatly into the standard models we use for natural interstellar flotsam. A typical visitor just falls and fades. This one seems to listen, and then adjust, as if it woke. The precedent that still haunts the field we've been here before, in a way. In 2017, Oumuamua swept past, lengthening into headlines for its odd shape and quiet acceleration. There was no obvious outgassing, no visible thrusters, just a persistent push that fueled 1,000 papers and more than a few arguments. Harvard's Avi Loeb floated the light sail hypothesis, an artifact traveling on the pressure of starlight. Many recoiled from that leap. Most retired the idea with a shrug. And yet, with 3I Atlas acting up, ears are open again. One detail, especially, is hard to ignore. Both objects appear to have arrived from broadly the same direction in the sky. The odds are so low that a new phrase is taking root: directed trajectory, a lone wanderer, or part of a system. If two interstellar bodies show up from similar coordinates and one starts behaving as if it knows what it's doing, the imagination doesn't need much prompting. Are these fragments of a larger architecture spread across the void? Are they probes, seeds, echoes of a distant culture that solved problems we haven't learned to ask yet? Patterns matter in science. So does restraint. But there's a sobering tension when patterns that imply organization keep stacking up in data sets that should prefer randomness. Design loves symmetry and rhythm. Geology typically does not. Plotting the path forward. Analysts at NASA's Jet Propulsion Laboratory have been crunching the come and go of the breakaway object's motion. The trajectory isn't merely outward. It curves in a way that suggests guidance rather than gravity alone. Extrapolations, hazardous though they are, leave room for a future that brings the object into more favorable viewing geometry, possibly even within range for high-resolution imaging campaigns by Webb or other assets. If that happens, the next frame we capture might not just raise questions, it might answer some, reframing the mystery. Pause for a moment and look up, from wherever you are. The stars will look the same, but they won't feel the same. Every point of light could hide a story as complicated as our own. Suppose 3I Atlas isn't just debris. Suppose it's a courier, not alive in a biological sense perhaps, but purposeful in a way that blurs our instincts about what alive means. In the hours before the detachment, infrared sensors recorded a clean thermal pulse, as if something inside 3I Atlas reached a threshold and crossed it. No solar flare, no impact, nothing outside to pull the trigger. The heat appears to have risen from within. If this is ordinary comet physics, it would be an exquisite piece of timing. If it's engineered, it might be a dormant instruction, set waking in the presence of a warm star after an interstellar winter. The cautious posture and the chatter underneath publicly, NASA's messaging is careful. An internal pressure pocket could have burst, much like the venting we observe when comets approach the sun. The model is familiar. It comforts. Yet multiple people with access to the telemetry concede that the numbers are misbehaving. The shape of the ejection, the symmetry of the fragment, the smooth, continuing acceleration, they add up to a puzzle the standard handbook doesn't solve. Outside the big agencies, smaller observatories are releasing their own sequences. In some stacks, the fragment appears to scintillate. Faint green and violet glints that come and go on a steady beat. Analysts have started calling it the heartbeat of Atlas. Whether it's a signal or an artifact of rotation and reflection remains unsettled. What is settled is that something changed, and that we watched it happen. Why this resonates beyond the lab, we explore because it rearranges our sense of proportion. Daily life has a way of shrinking our horizon to the width of a screen or a schedule. Then a story like this cracks the ceiling and floods the room with scale. Perhaps intelligence is wider than cells and synapses. Perhaps memory can be stored in hardware that outlasts its makers, adrift in a medium as old as time. Perhaps the cosmos is a mesh of networks, stars as switching nodes, galaxies as clusters, interstellar couriers as packets of meaning. Where the next data will lead, deep space tracking is now pulling double duty, keeping tabs on 3I Atlas and on the piece that slipped its grasp. If the measured acceleration holds, if it continues to demonstrate a consistent push, this would be the first time an interstellar object in our neighborhood has shown self-propulsive behavior in a way that survives scrutiny. That would rattle more than a few assumptions in physics and engineering. It might nudge open a door into a new category of presence in the universe. What's your read? Do you see a rare natural sequence stitched together by selective attention? or a whisper of intent from far away and long ago. The value for now lies in admitting we don't know and in refusing to be embarrassed by the size of the question. Curiosity has always been our best tool. Skepticism is not cynicism. Wonder is not gullibility. Hold all three at once. If this story moves you, tell someone who still believes the night sky can surprise them. And if you're inclined, share where you're following this from. This is as much a collective experience as a scientific one. A look beyond the edge. Imagine a future when we've built our own interstellar messengers and watch them fade into the dark. Somewhere, on a hill under an unfamiliar constellation, another species might see one of ours split open and ask what just slipped free. Maybe they'll weigh the same two possibilities we're weighing now. Maybe they'll feel the same uneasy thrill. As 3I Atlas recedes and the fragment rights its slender arc, remember, we are among the first to witness this, to feel an old silence break, to suspect that what left that object wasn't merely debris, but a sentence composed in photons and timing. It may be that the universe has never been mute, only subtle, and that, at last, we are learning to hear.